All right, so let's see what we've got going on here. Problem number 9. And again, for me, I believe that is 1.2.35. All right, so what we're supposed to do is determine the function in that form. That's your standard graphing form. Usually A is a stretch factor or flips. H is your left and right movement. And remember, it's backwards. Minus is to the right, plus is to the left, and a plus K out here. Sometimes they'll say HK, actually, if it's a minus here, that will actually be your vertex. So this 2, 7, we can put that in those 2 spots. So that's a -2 though, is it not? I think it looks like it's to the left. So it would be minus a -2, which would be like a +2. So then we're going to look at what's called the stretch factor after that to see how much it's gone up and down. I'll show you, maybe I'll show you a couple of different ways you can actually figure that out. I'm going to leave that A out there so I don't forget I got to do that yet. I got to figure that out. And then X minus -2, but that looks kind of funny to me. I think it makes more sense to just do +2 and remember that those signs are backwards there. Shift 6 for the caret to get into the exponent again, squared, and then arrow to the right to get out of the exponent. And then we went up 7, so +7. Now the stretch factor A out here, how are we going to do that? So remember first of all, normally our parabola opens up. So I know A has to be negative for 1. So if I come down here, this A that's out here, the negative is what flips it to be opening down, taking all those positive numbers and making them negative. And then normally for the first point, I think we've talked about this before, on a parabola, your first point, if it's your standard parabola, just x squared, you go over 1 up 1. So if you look over here, I'm going over 1, but this is going down 1, 2, 3, 4, looks like 5. So I believe just by looking at that right there, that you're going to need a 5 here. But let me show you another way algebraically to figure that out. That's from the graph how you can figure it out. But that's nice when you have an even number, but sometimes it's not exactly an even number. So remember this f of x is like y, right? And then let's say I don't know what that a is. And then we still have this x plus 2 squared plus 7. Well, what you can do is you can go over here and take a specific point you know. 0, 13, for example. You could have picked any of them that looked like they went right through a grid line, or the intersection of grid lines like there. 0, 13. Well, the 13, that's a -13, right? That's a y. So what you do is you put a -13 in here for y. I still don't know what a is, the stretch factor. That's what I'm trying to figure out. And I know the x that went with that -13 is 0. So I put a 0 in for this x right here. I put that -13 in for that y. And then now the only variable I have left is a. Now remember, from what I said, looking at this normal growth of being 1, I think it's a 5. I think it's going to be a -5, but algebraically to check to be sure, you can use this method with an equation. So I've got -13. A 0 plus 2 is 2 squared is a 4, right? And then plus 7. Okay, so now we're trying to solve for a to find out. That's what we wanted to know. Is this really -5? So the next thing I'm going to do is subtract that 7 to the other side. So -13 minus 7, that's -20, right? Then this 4 times a is what we have left here. And what is a if you divide by the 4 to solve, or just looking at it and thinking 4 times a -5? So that was correct also by looking at the graph. So there's a couple different ways that I've learned through the years that you can figure that out, and hope that helps you to get this one right on your problem, because I just got it right on mine. All right, good luck.